This video will show examples of geometric series. Find the sum of the series 7776 plus 1296 plus, and we're going to add all the way down until 1 over 36. So we can tell from this that our first term is 7776. And then to find our ratio, we can divide the second term by the first term, which gives us 1/6. And then we know that our last term is 1 over 36. We can plug these numbers into our alternate formula for the sum, which was G1 minus GNR over 1 minus R. So that gives us minus 1 over 36 times 1/6 over 1 minus 1/6. And calculating the math, we find that that ends up being 9,331 and 7 over 36. Find the sum of the series. The first term is 8, ratio is 2 over 5, and we're taking the sum of the first 5 numbers. So all we have to do here is plug it into our formula, the first one, which was Gn G1 R to the n over 1 minus R. So that just becomes 8 minus 8 times 2/5 to the power of 5 over 1 minus 2/5. 8 minus 8 times 32 over 3,125 over 3/5, and simplifying all of the math, what we end up with is the sum equals 8,248 over 625. You want to convert this series to sigma notation. So the first thing you want to do is come up with the nth term formula for the sequence. We know that our first term is 96. Our ratio is 48 over 96, or 1/2. So that gives our nth term formula as 96 times 1/2 to the power of n minus 1. Now we know that we have our sigma, n equals, we can go ahead and plug in our formula that we found. And now we know that we're starting from n equals 1 with the 96. So we can go ahead and write that in. And now we need to find out what n corresponds to 3 over 2. And the way we do that is we can plug that into our formula. So 3 over 2 equals 96 times 1/2 to the power of n minus 1. So 1 over 64 equals 1/2 to the power of n minus 1. N minus 1 then equals 6, or n equals 7. So now we can just take the 7 and plug it into our sigma, and we're done. Evaluate this sum in sigma notation. So if we look at the function we have beside the sigma, we can see that we're taking the sum of numbers of a geometric sequence, because this is the formula for a geometric sequence. And using that, we can say that our first term is 5, so G1 equals 5. And then we're multiplying each subsequent term by 1/2, so that means that R equals 1/2. We're going from n equals 1 to 10, so that means we're summing the first 10 terms. So n equals 10. So now all we have to do is plug this into our formula. g1 minus g1r to the nth over 1 over r. So that's 5 minus 5 times 1/2 to the power of 10 over 1 minus 1/2. And if we plug that into the calculator, we get about 0.99.